Solving Systems of Non-Linear Equations, Chapter 10, Lesson 3. Okay, in previous chapters, we have learned solving systems of equations by graphing, substitution, and elimination. With non-linears, we have stipulations on which method we can use. So we can use elimination to solve two nonlinear equations only if the exponents are the same. So we can only basically do elimination on ellipses, circles, and hyperbolas because they all have the x squared and y squared. So we'll use substitution for those when the exponents are not the same. So if we're trying to figure out where a line and a circle, so a line is just y equals mx plus b, and a circle, which is x squared plus y squared equals c, if their exponents are not the same. So then we would use substitution. So we're looking at these first couple. The first thing I would usually do is determine which type of sections conic sections you're dealing with here. So this top one we know is a circle whose center is at 0, 0, and whose radius is 5. And then the second one we have is a 4x plus 3y. So we know that this is a linear. And if I subtract the 4x and then divide by 3, so start at 0, down 4, over 3. And we're trying to solve these two intersection points here. We're trying to figure out where did they cross. Since it's a line into a circle, I know that there are two intersection points, and based on the graph, I know that they're going to have two. Now, you don't have to graph it. I just did so that we could tell what we're talking about. However, since I can't do elimination on these, since the top one is an x squared and the bottom one is just an x, I would have to get this into y equals form anyway so that I could substitute it into the y term. So that will give me, I'm going to have to erase this graph so that I can have room to work. I only want to erase the graph though. Just the graph, please. Just the graph. Right? All right, so I'm going to have my original circle equation, so x squared plus, and then instead of y, I'm going to have negative 4/3 x squared equal to 25. That would give me x squared plus 16/9 x squared equals 25. This is a 1, so when I take 1 plus 16/9, 1 plus 16/9 gives me a total of 25/9 x squared equals 25. Divide by 25/9 on both sides. So x squared is 9, correct? Yep. And then undo the square, take the square root. So 3 and negative 3. And I knew there was 2 points. Again, I erased the picture, but it was like this. It would make sense that this point here is at 3 comma something, and this one is at negative 3 comma something. So far I know it's going to be 3 comma and negative 3 comma. All right, now I'll take those x's and I'll put them back into the circle, like normal substitution. So I'll have y equals negative 4/3. And then on the first one, I'll have 3. And on the second one, I'll have negative 3. So that gives me, for the 3, it gives me negative 4. And for the negative 3, it gives me positive 4. So that would make sense that this is crossing, I had that picture up, but this is crossing at negative 3 comma 4, and this one is 3 comma negative 4. Now you can use your Desmos graphing calculator to check this. So I had x squared plus y squared equals 25 and y equals negative 4/3 x. Oops, x needs to be there. Good. And we check them here. I got negative 3 comma 4 and 3 comma negative 4. All right, let's look at number 2. Need some room to work here. Okay, number 2, I'm starting with another circle. Actually, no, it's not a circle, sorry. It's an ellipse. Because when I divide everything by 4, that would give me x squared plus y squared over 4 equals 10/4. So I don't need to do that. I just need to know that that is why it's an ellipse, not a circle. And the bottom one, obviously, y equals 1x is linear. So kind of the same, I'm going to do it like over here. We're kind of looking for the same type of thing, 2 crossing points. So I'm going to take my y equals x and put that in substitution for my y squared. So my top equation becomes 4x squared plus x squared equals 10. So 5x squared equals 10. X squared equals 2. X equals, and we normally are just going to leave it as the square root of 2 and the negative square root of 2. We'll look at those decimals once we go to graph it on the Desmos, but for now we'll leave it like that. Okay, so those go back into the solutions. Then I can sub them back into here. So instead of y equals x, I'm going to have y equals the square root of 2 and y equals the negative square root of 2. So if I do the square root of 2 on my calculator, we're looking about 1.4 comma 1.4 and negative 1.4 comma negative 1.4. So let's check our Desmos. 4x squared plus y squared equals 10 and y equals x. So there is our positive 1.4 comma positive 1.4 and our negative 1.4 comma negative 1.4. And you can see this is our ellipse with our linear line going through it. Okay, number 3. On the top here I have a circle, and on the bottom I have another linear. Y equals negative 1x minus 2. So I'm going to take this y equals negative 1x plus 2, sub it in for y. So my top equation becomes x squared plus, and instead of y, I'm going to have negative 1x minus 2. Squared means to multiply it by itself, so I'm just going to go ahead and write it out twice. Equals 4. So then I'll have x squared plus 1x squared plus 2x plus 2x plus 4 equals 4. So 2x squared plus 4x plus 4 equals 4. Subtract the 4 plus 4x equals 0. Take out the greatest common factor of 2x. Then I have two options here. So either 2x equals 0 or x squared plus 2 equals 0. So x equals 0. And then x squared equals negative 2. And when I try to take the square root of negative 2, I get a non-real answer, or plus or minus I square root of 2. So since I got a non-real answer, what this is telling me on this one is that I have a circle with a line that just is touching it once. That's what this non-real means. But I do know that one solution, this solution here, is at 0 comma something. So I'm going to take that 0 and put it back into here. And I'll get 0 comma negative 2. Okay, so let's look at this one. X squared plus y squared equals 4. And y equals negative 1x minus 2. Oh, it says I should have 2. Oh, because I solved for my x 0 comma negative 2. I had that. Why didn't I get this one? Negative 2 comma 0. Okay, so to get that negative 2, best I can figure is I should have put it into the original equation instead of into the circle here. So if I put it back up in here, x equals 0, then I will get 0 squared plus y squared equals 4. And then when I take the square root, I get 2 and negative 2 for my y's. So that would give me my 0 comma 2 and my 0 comma positive 2. But that's not right either. Okay. On this last one, number 4, they are both squared. And so I can do elimination on here. However, in order to do elimination, my variables need to be the same coefficient but different signs. I'm going to go ahead and go for the y's. So I'm going to multiply this by negative 2 and this by positive 3. So my new equation is going to be negative 8x squared minus 6y squared equals negative 70. This bottom one will be 15x plus 6y squared equals 126. So now I can cross them out. Negative 8 and positive 15 would give me 7. Negative 70 and 126 is negative 56. Positive, sorry. Divide by 7. Negative x squared equals 8. So for right now, I'm just going to leave it as the square root of 8 and the negative square root of 8, and we can investigate those decimals in a minute. Those need to go back into either equation for x, so I'm just going to go ahead and put them into the top equation for x. So I have 4 times the square root of 8 squared plus 3y squared equals 35. So when I do this one, I'm going to get 32 plus 3y squared equals 35. Subtract the 32, which gives me 3. Divide by 3, which gives me 1. And I've now gotten 2 y's, 1 and negative 1. And that was when I just put in the square root of 8. So that tells me when I put in the square root of 8, there's 2 answers. And when I put in the negative square root of 8, I'm also going to get 2 answers then. And the reason for that is I have 2 ellipses here that are crossing. And they should have 4 intersection points. So we'll go ahead and look at those. And just for frame of reference on our decimals, the square root of 8 is 2.8. So 4, 3, 35. 4, 3, 35. 5, 2, 42. 5, 2, 42. So you can see here, they do have 4 intersection points. And again, we took the square root of 8 was 2.8. And so you can see we have all the different combinations of the 4 of them together. Okay, here's some more practice with more substitution practice here. Oh, we've already done enough substitution, though. Let's do this elimination one down here. So in order to eliminate, I need to either multiply this by 2 or by -1, which would probably be quicker so that those cross out. 3y squared will now equal 9. So y squared is 3. So y is the square root of 3 and the negative square root of 3. Put those back up in for y. X squared plus 2 times the square root of 3 squared equals 10. So x squared plus 6 equals 10. X squared equals 4. And x equals 2 and -2. And once again, since I've gotten 2 solutions, when I put in my 1y, I know that there's going to be 4 total combinations. I am putting them, making sure I'm putting the x where it belongs and the y where it belongs in these coordinates. And for a frame of reference, the square root of 3 is 1.7. So 1, 2, 10. 1, 2, 10. And the bottom one I see is a subtraction. So this is going to be a hyperbola. So it was 1x squared minus 1y squared equals 1. Since it's a minus, it's going to be a hyperbola. There. And they cross at those 4 points we listed. Again, the square root of 3 we referenced as 1.7.